All right, so let's start off with a review of some confidence interval stuff. So this is a page of the book from section 3.1 about what's a sampling distribution. And the point here was that sample size matters. So check out this graph here, and does that blow it up maybe? Like this. All right. So here they have, from the data in StatKey, a proportion of college graduates in the US. And we have a proportion of, from a sample, we're estimating that in the population in the US, there's 27.5% of people have a college degree, adults. Now, the sample size that this comes from matters. So down on the graph below, they have a sample size of 1,250. And the scale at the bottom is the same for all of these. So when they run, let's say we go do samples of size 50. So I go out and I take a sample of size 50, Bree goes out and she takes a sample of size 50, meaning she just randomly selects 50 US adults and says, hey, do you have a college degree or not? And we come back and we report the numbers that we got. So then we get thousands of people to do that. And once we all come back and report what we found from our sample of 50 people, that's a sampling distribution. So there's a whole bunch of points here. You know, maybe they have 2,000 different samples here, each of size 50. And there's a wide range of what those samples reported back for what the proportion of college graduates was. So somebody's sample came back with about 10% of people were college grads. Somebody else came back with around 45% of people with college grads. But most people found it was like between 20 and 35% of people were college grads when they did a sample of size 50. Now, if we up that sample size to 200, we're going to find less variation in the results of our samples. So now we go out again and we get like, 2,000 people and say, okay, every one of you needs to go randomly find 200 adults and ask if they have a college degree or not, and then come back and report what proportion had a college degree. So here, the low is around what, maybe that's 17% of the people in that sample had a college degree. And over here, the high was around maybe 38, 39%. But most of the samples of size 200 came back with people that had college degrees were somewhere between, looks like, let's say 22 and 32% had college degrees. If we up the sample size to 1,000, what we're going to find is that the results of the samples that come back are going to have a much narrower range. So what this tells us is that if we want a smaller margin of error, we should increase the sample size. Now the question is then, can we afford to increase the sample size? But that's what this graph is showing here. So this one down here has a very very large range for the small sample size. And if I wanted to say estimate what the standard error or the margin of error was here, I would think about the 95% rule. So let me just sketch on that a little bit. This page is fine. And I think I just want this one first. So with this one right here, I want to kind of estimate the standard error. And remember, standard error is the standard deviation for sampling distribution. So what might the standard deviation be here? And remember the 95% rule, also known as the 2 standard deviation rule. So if I look at this and I try to guess, okay, where would about 95% be, and then 5% in the fringes? So I might guess from like over here over to here is about 95% of the samples. So if I put 95% in the middle, then the tails, this should have 5% to split. So there should be about 2.5% of the samples should live over here, and about 2.5% of the samples should live over here. So I think 95% of the samples live within this range right here. And so let's say my range is 40 to 15. So if I look at that width of this here, that would be 40%, 0.40 minus 15%, 0.15. What is that on a good day? 25%, 0.25. So that 95% is that 2 standard deviation rule. So the mean is in the middle. And then we looked 1, 2 standard deviations to the right, 1, 2 standard deviations to the left. So altogether, this width of 0.25 is about 4 standard deviations total from the 2 standard deviation rule. So if I take that 0.25 and I divide by 4, can't do that in my head. Today.
So you're really just guessing, though.
You're just looking at that and you're just guessing at around what would the standard deviation be there.
Because that, yeah, that was what was really throwing me off. Was like, I don't know how to. I was looking for how do you find that exact number based on that graph? Yeah, and I'm like, so, I don't know how to do that.
So it's just to look and guess at what the spread is. And so I got to look back at what the question here asked. If they asked about the margin of error or the standard error, because those are 2 different things. Oh, this one doesn't have it right there. I thought, oh, down here it is. Okay. So they're asking about standard error, which is standard deviation. So I'm trying to guess the standard deviation of the graph. And they explain how they came up with that idea, which is pretty much what I'm doing here. So I'm just kind of going through their explanation there. So 95% rule says from the middle, go 2 standard deviations to the right, go 2 standard deviations to the left, and that should be 95% of the data. If you do that, then you've basically split this region into 1, 2, 3, 4 chunks. I think the width of that region is about 0.25. 0.25 divided by 4 is 0.0625. So that's my estimate of the standard deviation, which is also referred to as the standard error here. So you're just supposed to look at the graphs and estimate those numbers to the best of your ability. And this is their explanation. I find it a little easier to draw a picture and figure that out. So they're saying about 0.063. I was thinking 0.0625. We're both in the ballpark on that one right there. So if we try that on the 200 one, let's give that a shot for fun. This picture. I need to see the picture with the scale. So let's see if I can superimpose that. That's not too bad, I don't think. So if we look at this right here, we want to estimate, all right, where would the middle 95% rule, middle 95% be? So again, 95% rule is what we're thinking about here, which is equivalent to the 2 standard deviation rule, which means identify where the middle is. So I think the middle is about here-ish. And then I want to find 95% of this data. So maybe that's about here and there. So that is what I think the middle 95% is. So then the width of that would be 35% minus 20%, which would be about 15%. And then the 2 standard deviation rule, that 95% means we jumped 1, 2 standard deviations to that side, 1, 2 standard deviations to that side. So we just split this into 4 chunks. So my explanation is a little bit different than the book one, but I like pictures better. So if I cut that into fourths, what do we get? That should be about 0.04-ish, 0.3-ish. About 0.04 if we round. So I think that's about the standard deviation of this graph right here. So that's my estimate of the SE. Moment. All right. So hopefully that helped about the 95% rule, the two standard deviation rule, they're one and the same, and how graphs can help. And most of the time when I analyze problems like this, I either get a picture of a graph from StatKey or I sketch out my own. And sketching out our own would be just estimating some kind of bell curve like that and talking about the middle and where those marks are on each side. So let's review an example from last week that's similar to that.